Bismillahirrahmanirrahim. In this lecture, we have to explain geometric sequence or geometric progressions. Now, what is geometric progressions? Uh, a geometric progression is a sequence of numbers, each terms of which after the first is obtained by multiplying the preceding term by a constant number called common ratio. Common ratio is denoted by R. Example of uh, geometric progression is 2, 4, 8, 16, 32, and so on. This is geometric progression because here the value of R is 2. R is 2 multiplied with 2 give us 4. Uh, 4 multiplied by 2 give us 8 and so on. Because each number is obtained by multiplying the preceding number by 2. Uh, 2, 4, 8 and so on. Another example is 4, 12, 32. This is the example of geometric progressions. Note, in geometric progressions, the ratio between any two consecutive terms is remain constant and is obtained by dividing next term with the preceding term. Here next term is uh, an, next term is an, and preceding term is a power n minus 1. So here common ratio is defined as a n divided by a n minus 1. This is common ratio. For example, if we consider two, uh, if we consider 2, 4, 8, 16, and so on. So the next term is here 4 and preceding term is 2. So common ratio R is equal to 4 divided by 2. So this is equal to 2. So here constant term is 2. Next one, nth term, nth term or general term or last term of geometric progressions. If A is the first term and R is the common ratio, then the general term of geometric progression is A, AR, AR square, AR power 3 and so on. So here the first term, here the first term is uh, A1 is equal to first term is A. Second term is A2 which is equal to AR. Third term is AR square and so on. So general term AN uh, AN is equal to AR raised to the power n minus 1, which is the inner term of geometric progression, in which uh, A1 is first term, R is common ratio, and N is the number of term, and AN is the last term or general term. Uh, Next, Example 2. In example 2, write the sequence in which a1 is equal to 5, r is equal to 3, and n is equal to 5. Here a1 is equal to a is 5, so a2 is equal to ar. So if we put a is 5 and 3 and r is 3, 5 multiplied by 3 give us 15. Uh, so a2 is equal to 15. Now a3 is equal to a3 is equal to a2 into r, but we know from previous that a2 is 15, so 15 multiplied by 3 is equal to 45. Next term a4 is equal to a3 multiplied by r, but a3 is equal to 45, so 45 multiplied by 3 is equal to 135. Uh, Fifth term is equal to a4 multiplied by r, but a4 is 135. If we put a4 is 135 and r is equal to 3, then 135 multiplied by 3 is equal to 405. So the required sequence is 5, 15, 45, 135, 405. Next, find the fourth term in the geometric progression 5, 10, 20, and so on. Here, the value of first term a is 5, the value of r is 10 divided by 5, so is equal to 2. We have to find an, but we know that an is equal to ar raised to the power n minus 1. So a4 is equal to a1 ar raised to the power n minus 1. A is 5, a is 5, and r is equal to 2, and n is equal to 4. So if we simplify this term, if we simplify this term, this is equal to 40. Next example, example 4. Find n. Find n means number of terms. Number of terms. In the geometric progression, 4, minus 2, 1, and so on. But here we know that uh, given that an is equal to 16, an is equal to 1 over 16. So since sequence 4 minus 2, 1, and so on, here a is equal to 4, the value of r is minus 2, n is equal to, the value of r is equal to minus 1 over 2, minus 1 over 2. Here are some mistakes. The value of an is equal to 1 over 16. Now we know that an is equal to ar raised to the power n minus 1, because the general term of the geometric progression is ar raised to the power n minus 1. But we know that here an is equal to 1 over 16. The value of a is 4. The value of r is minus 1 over 2. 1 over 16. If we multiply, uh, if we simplify this term, in last we get that 1 over 16, 1 over 64 is equal to minus 1 over 2 whole power n minus 1. So minus 1 over 2 whole power 6 uh, is equal to 1 over 64. If we compare both sides, n minus 1 is equal to 6. N minus 1 is equal to uh, n minus 1 is equal to 6. So n is equal to 6 plus 1. N is equal to 7. So the value of n uh, becomes 7. Next term, next example 5. Find the geometric progression of which the third term is 4 and the sixth term is minus 36. So given that A3 is equal to 4 and A6 is equal to minus 32. Uh, Now we know that an is equal to a r raised to the power n minus 1. If we put n is equal to 3, so a3 is equal to uh, a r raised to the power 3 minus 1 and a6 is equal to a r raised to the power 6 minus 1. So a3 becomes r r a r raised to the power 3 minus 1 and a6 becomes by using general term a r raised to the power 6 minus 1. So a3 uh, a3 is equal to 4, a3 is equal to a3 is equal to 4. So replace a3 by 4 is equal to ar power 2 because 3 minus 1 is 2. And here sixth term is minus 32. So this is equal to ar raised to the power 5. Dividing dividing equation 1 by 2. Equation 1 by 2. ar is ar power 2 divided by r power 5. A cancel with a. So 1 over r power 3 is equal to minus 1 over a2. R power 3 becomes minus 8, but minus 8 is equal to minus 2 whole power 3. So this becomes the value of r is minus 2. The value of r is minus 2. Now the geometric progression become geometric progressions become a1. Now by using equation 1, the value of uh, r4 is equal to uh, 4 is equal to a minus 2 whole power 2. So by simplifying this, 4 is equal to a multiplied by 4. So this become a is equal to 1. So geometric sequence become 1 uh, minus 2, 4, minus 8. This is the required geometric progression. Example 6. The population of a town is at the increase at the rate of 10% annually. Its present populations, its present population is 2 lakh. What will be the population at the end of 5 years? Let the present population is A. So this is a given that 2 lakh. The increase of population at the end of first year will be A multiplied by 10%. So this is equal to A into 0.1. Total population at the end of first year will be A plus A into 0.1. This become A into 1.1. 1.01. Total population in the end of second year will be A in A into 1.1 multiplied by 1.1. So this become A into 1.1 whole power 2. The population at the end of fifth year is the sixth term of geometric progressions. So first term is A, second term is A into 1.1, third term is A into 1.1 whole square. So here the value of A is 2 lakh, the value of R is 1.1 and N is equal to 6. So by the value, putting the value, we get the sixth required sixth term. Thank you so much for watching this video. Please subscribe the channel.